welcome, 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 welcome. Okay. What are we talking about? We are talking about this. Oh, I wonder if I can have my papers. So we're going to be counting 1, 2, 3, 4, and then 5. So, hello, Andrew. Hello, Carlos. We are going to be talking about, we're going to be mathing in the middle of the night. I'm not sure where you guys are, but that's what I'm going to be doing. So, this is an abacus. An abacus is a counting tool. This counting tool will help me learn how to add, subtract, multiply, and divide. And division. And decimals. Sorry. So, what are we doing? We're counting 1, 2, 3, 4. Why? Because we need to learn how to read the abacus before we can start doing all these other crazy things. And we can do a lot of crazy things. So we have 4 and then 5. So what does this mean? This means that there's this horizontal bar. Hello, everybody. Hello, Lisa, Granny of 4. So this horizontal bar tells me that these beads are being counted. Because these beads are being counted, this is the only one that's being counted right now. Right now. So what does that mean? So if I do this, this is 6. Let me know if you have any questions. So, hello, McDon and Strata. Okay, so we have 6. How do I know? Because this is all the lower beads. Anything underneath the horizontal bar has a value of 1. And then anything on the top has a value of 5. No matter what, this is 5, this is 5, that's 5, that's 5, that's 5. So these are all 5s. But I'm going to zero it out. I'm going to zero it out. And now I'm going to count. 1, 2, 3, 4. And then 5. Ooh, 5. We have 6, 7, 8, and 9. And then we have 10. Oh my God! Why? Because if you look, there's a dot here. This dot tells me, it indicates where I put my ones place. So this is where my ones is. So I have my 1, 2, 3, 4. And then I have 5. This is 5. 6, 7, 8, 9. And then what I'll do is I'll count to 10. Now this is 10. How do I know? Just like how we write 10. Let's see if I can find my papers. Just like how we write 10, right? 1 and a 0. Just like how we write 10, it's the same thing. It gets translated to abacus. This is my 10s, this is my 1s, and this is my 10. So, thank you so much for joining my live. Hello, everybody. Let me know if you have any questions. So we're counting. What we're doing is we're learning how to read the abacus. When we learn how to read the abacus, this counting tool, then we can go into more arithmetic, which is adding, subtraction, multiplication, and division. So we have 10, right? We have 10, 11, 12, 13, 14, and then 15, 16, 17, 18, 19, and then 20. We are mathing in the middle of the night. So we have 20, 21, 22, 23, 24, 24. So if I did this, this would be 524. How do I know this is 500? This is 500 because when we count, just like the placement value of our numbers, we have our ones, our zeros, our ones, our tens, our hundreds, our thousands, and our 10,000. So if you look, there are 2 dots. I could do this dot, or I could do this dot. Now, does it matter? It doesn't matter. You just choose a dot and go with it. So if I choose this dot as my ones, then I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Are we good? Are we good? Thank you so much for the hearts. Thank you so much for the hearts. We are learning to read the abacus. When we finish learning to read the abacus, we can go on to adding, subtraction, multiplication, and division. So, just laying the groundwork on how to read the abacus. Yes, I found it. So, I'm actually in the process of creating my new book. So, if you look, we have a little picture of the abacus, and this picture is, here's the top bead and here's the horizontal bar. This is the horizontal bar and these are the bottom beads. There's 4 bottom beads, but this one is 2. How do I know? Because this 2 have 2 beads touching the beam. And now I'm just going to be coloring on live. I want to learn how to multiply. Jose the Panda, you're here. Let's do some groundwork first, and then we'll go into that if we have time. Yeah, if you have time, actually, I'll be here all night. It depends. Anyways, so what are we doing here? Okay, cool. Yeah, I've got some questions that we could do. So this is what 2 looks like on the abacus. We have 2. If you want, Jose, let me know if you have those questions ready at hand, and then we can do it. Okay, you know what? So this is 2. How do I know? Because there's my horizontal bar, right? My horizontal bar is my horizontal bar. And then I have these 2 beads. That's what this means. So this is a picture of representation of this, right? This is my abacus, and we're learning how to read. So just like we did here, this is 0. 0 means none of the beads are touching the beam. This is 1. How do I know this is 1? Because I have 1 bead touching the beam, and that's what it looks like. Good morning, Lady E. Hello. Ooh, that is early for you. Hey, Lady E, do you guys have to do daylight savings? I'm not sure. I know America still does it, and I don't know when we're going to stop, but we still do it. Okay, so again, this is 2, right? This is 2. This is a sneak peek, Lady E, of my new book for adults. So I'm making my new book for adults. And so we'll see. This is the beginning pages. So we'll see. So this is 2. So we have 2 and 2. And then again, we have 3, right? We're going slow because I know I talk a little fast. So we have 3. How do I know? Because we have 3 beads. 1, 2, 3. And then we have 3 on the abacus, right? We have 1, 2, 3. So this is just a little, this is, yeah, I'm still trying to do it. And I think I'm going to keep this because then I think I want the adults to color it in. I think I'm going to keep it like that. So this is 4. How do I know that this is 4? This is 4 because we have 4 beads touching the beam. Notice there's no bead at the bottom. So we have 4. 1, 2, 3, 4. Anybody have any questions? We're taking it slow because I know the last time I did this, I went a little bit too fast for everybody. So I want to take it slow just to keep track, if it's okay with everybody. So we're going to do 5. How do I know that this is 5? This is 5 because we have the top bead. In the picture, the top bead is touching the top bead is touching the horizontal bar. So on the abacus, that's what it looks like. This is 5. So then what happens? Well, this is 6. How do I know that this is 6? Because I have 1 bead on top, which is 5, and then I count 5, 6. And then I'm just going to color it in. Maybe I keep it hollow and get it to be colored. I think I'm going to do that. I had it colored in, but then I'm thinking, okay, anyways, I'm just mumbling now out loud. So again, this is 7. How do I know this is 7? It's 5, 6, 7. So we're mimicking the picture to the abacus. We're mimicking the picture, right? So, and this is concrete. Well, for you guys, it's still a picture in picture, right? But for me, I could feel it, I could touch it, I could move it around, right? So it's different. So you guys all need to get an abacus. That's what you guys need to do. Lady E, did you get an abacus? Jose, did you get an abacus? You guys got to get an abacus so we could all do it together. Hey, Eric, how's it going? Whoa, 19, 17 people in the room. 18. Woo, thank you, everybody, for so much for the hearts. Okay, come on. You guys got it. Ooh, you have one. Yeah, I have not, but I want to. Boy, you got to get one. Okay, so I don't know where you are. I love your channel. Thank you so much. Thank you so much. Hey, Jose, I don't know if you're around anywhere close to Daiso. Daiso sells abacus for $3 and something because Dandelion got hers from Daiso. I don't know if you know what Daiso is. It's a Japanese, like a 99-cent store, but it no longer 99 cents. So this is 8. We're at 8. What am I doing? I'm just coloring it in, and I'm taking it slow because I know I talk fast. So this is 8. How do I know? 5, 6, 7, 8. 5, 6, 7, 8. Thank you so much for liking my channel. I love my... Thank you. Why is the most left one being skipped? Eden, because we're talking about the tens. So this is the ones. If you notice, I have a dot. This is in my indicator. My indicator tells me, my indicator indicates that this is my ones place. That's why. So when we do it, when we do 9, right? When we do 9, I'm just going to color in 9 so I can keep my thought going. No offense. I'm just trying to keep my thought going because, talking. Okay. So notice I have 9. So now the question is what happened to 10? This is where we get our 10. So this is our ones and then this is our tens. So when we do 10, that's what it looks like. That's what 10 is. How do I know? 1 and 0. Just like how we write it. Just like how we write it. 1 and 0. So this is our 10. So when we look, we could do 11, 12, 13, 14, right? Now I can go super fast because everybody knows how to count, right? Everybody knows how to count. So we have 14, 24, 34, 44, 45, 45, 65, right? 75, 85, 95. And then wait a minute. What are we going to do? There's no more hundreds, right? Because it's the columns. This is the ones, this is the tens. Well, notice I have a dot over here. These dots will help me. So you can choose any dot you want. So that's the beauty thing. But wait, there's more. That's the beauty thing about having this indicators. So you can start from here. So then you have your ones, your tens, your hundreds, your thousands, and your 10,000. Make sense, Eden? I hope that's okay. Thank you so much for the follow, Lisa Grania 4. Eden, was that okay? Did that make sense? Right? Yeah. Oh yeah, right? Simple to use, easy to understand. But that's the thing, right? So then the question is what are we doing with these ones? Me too, right? Everybody, let's talk about it, because what I don't know, what you don't know, what you don't know, I might know. All right. So now the question goes back to, what about these ones? Well, if you notice, these ones will be their decimals. Hooray for more Abacus! Gina. You guys are so silly. Yeah, last night was crazy. All right. So we're back to here. These are the ones. So just like we have, just like how we have, what? Money, right? We have cents and we have our decimals. We have our cents and our decimals. We have our ones. So I'm going to do 3. Can you see that? You can't see. I can't see that. Okay, 3. So I do 3, right? 3 in my ones place. 0.25. So I put 20 and I put 5. See, notice how that. So I'm so happy I came across you on my FYP. Yeah, because I never got it, but you just explained it perfectly. Thank you. I'm so happy. I'm very happy to explain this to everybody and let them know, because this is not rocket science. Let me tell you, this is my secret. I know how to explain abacus really well. So my ones and my tenths, because that's a pain in my ass to be talking, tenths, and then the hundredths. And then obviously if I had more columns, it would be thousands and so forth. So it all depends on where you want to label your ones. So you could do your ones here or you could do your ones here. It doesn't really matter, right? You could choose. It's easy going. It's easy going like Jello, right? Jello is a little, I don't know. I'm just talking now. So we have $3. Let's say we call it in cents, right? So it's $3.25. Okay, we're good? We're good? Nice? Yeah? Let me know if you have any questions. We're going to continue on. But that was a really good question about why we're using the certain columns. So I'm going to continue on with my little book that I was going to create for adults. And it's going to be a little bit of coloring. Okay. So what I did here was I'm indicating the picture of what it is. So here I labeled it as my tenths, just as I did here. So I have my tenths, so that's 20, and I have my 8. To look at that, that's how I have it here. So I only did two columns to show the place value, my tenths, and then the ones. And then if you notice, there's a little dot there. I added a little dot. None of the ones I did before didn't add a dot because the kids don't care. But this one is about having a dot, and then this is 8. How do I know? Because it's 5, 6, 7, 8. So what I'm looking at is I'm just making sure I understand what 28 looks like. Thank you for the follow. Thank you, Sanchez. Sanchez Selena. I see. Welcome, everybody. Welcome. Okay. So I think I'm going to keep it hollow, so then adults will color it in like a coloring book, like a math coloring book. So this one is the same. I have my ones indicator here, and then my tens and my hundreds. So this is just to reinforce how to read the abacus how to read the abacus. This one is a picture, right? So I have 7, so I'm going to do 7, and then I do 4, and then I do 5. So on my abacus, I have 547. So, can you give us a random number and let us answer it? Whoa, what? Okay, let me do it. Let me do it. Okay, so we have 5 and then 4. Let me finish coloring. And I will give you some I would give you some questions. Cuz I was doing more of a book. Okay, got it. So, oh, you know what? Okay. Okay. Let's do this. Let's do this. Okay. Here's a question. Here's a number. Let me move this because it's gonna distract me. Okay, let me do that. So let's see. Let's do that so you don't see. Okay. So okay. Math coloring girl, I am your target audience. Yeah. Given one has been passed down, I figured I'd learn something. Yes, this is the day. Selena. Okay, here's the question. I'm not gonna say anything. I'm just gonna do it. Okay, now you tell me what this is. And I have to learn to be quiet and be patient. Because I'm the only one talking, so I don't know. I'm gonna show you. I gotta be quiet because I'm not quiet. Okay. So did I do this? No, I didn't. Okay. What do we have? What do we have? Okay. 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 So we have dots. Okay. So Lady E, I'm sorry. Why are you sorry? I don't know why you're sorry. Okay, 115. Okay, let's see. So we have there's a lot of people that just come in. Okay. So we have 4, 6, 3, 1, 5. Now, here's the thing. I am 1 a.m. woman. I know, right? Come on. Okay. Yes. Good. 4, 6, 3, 1, 5. Now, here's a question. Yeah, Gina, here's a question. Is my ones here or is my ones here? That was a question. I got it. Yeah. How do we read this? So, Lennox, before I continue on, that's the question, right? If I said that this is my ones, what would this be now? So we got it. If this was my ones, most of everybody got it when we got it here, right? So now the question is if it's over here, what would be it if this was the ones? 0.46315. Oh, Gina, too many zeros. Yes, LNC photography. Yes, moon. Yes, because this is my ones. So the dot happens between here. Gina, if it would have been up here if I did a 0. Does that make sense? Yeah. Okay. So Linux, let's see. We're gonna be counting. How do we count? Yes, Jose. Okay. So we're gonna do another number. Gina. Okay, we're gonna do another number. So Lennox, how we're gonna do is we're gonna count 1, 2, 3, 4. Easy, right? What is 0? What is 0? Bam! That's 0. That's it. That's 0. Now the difference is in school we always teach the kids to start from 1, but in Abacus we teach the kids to start from 0. So let's say 408. Well, if this is my ones, I do 408. Whoa, 8. Yeah, right? So Lennox, you're okay? Can I still count? Or am I going to do some adding and subtracting? So what I want to do is, what? Okay. So what are we doing here? Yeah, that makes sense? 408. Okay, so what we're going to do is we're going to continue on. I mean, that's what a 0 is, right? Just like when we write it. We do 408, just like how we write it. This 0 takes place in the tens. So we have 8, right? And then our tens and our 4. That's it. How do you decide where the ones is? It's up to you. It's up to you. The only thing that the only thing that it designates the ones would be where the dot is. These are dot indicators. It's just to help us label. So I chose this one so then I can have bigger numbers. You could choose this one if you want to have smaller numbers for decimals. So it is up to you, but I like to do this one. If you have a different kind of abacus, like this is a 13 column abacus. This one is a 7 column abacus. With a 13 column abacus, you can choose any dot. Usually I would start in the middle, if that helps, right? So the reason why is because then I can have millions. So let's count it. Ones, tens, hundred, thousands. We're making one. Oh yeah. Oh, Daisy, when you make it at least 5 columns. Make it at least 5 columns. So it'll be one in the middle, 2, 3, 2, 3, right? Make it 5. So then you can have more numbers. So when you do it, do that if you can. Or you can 3D print it. I don't know how you do that because it's a moving part. Anyways, so we're going to count on our place value. Ones, tens, hundred, thousands. So again, do you see my indicator? This indicator helps me understand where it is. Just like how we write thousands. When we write with a comma, it'll be comma. No, I don't like that. I like my Sharpies because I like it nice and bold. So 1,348. So this comma is our indicator right here. So then we have our thousands, 10,000, 100,000, and $1 million. Ooh, yes. This is so cool. No, just for fun. Yeah, just for fun. Do it for 5 because then you could still use it. I like to be versatile because just like how we understand what the formulas are, right? So, okay, so that's counting. Let's do another number. You know what? Let's do another number. I'm going to use this one because I like the colors. So I'm going to say, no more tricking. This is the ones. So we're all good. This is the ones and this is the number. What number is that? Okay, what number is that? Austin Powers, right? Hey, Melinda. How do you do math on it? Good night, Daisy. I'll see you later. Yes, Serial Queen. Yes, G Lit. Yes. How are we going to do? Yes, we can do adding, subtraction, multiplication, division on this abacus. User 77, I'm sorry, user 77, we forgot the decimal. The decimal happens between the ones and the tenths. So if we figured that out, like how it's being positioned, the ones is here where the dot is. So when it indicates the dot, the indicator is my ones. So after the ones is the tenths and then the hundredths. 887. Because we have to remember that the 5 gets counted. If the 5 is touching the top, if the 5 is touching the horizontal bar, it would be 8. Exactly, Gina. So it'd be 2, 4, 4, 8, 7. Cool? Cool. Yes, thank you. Diego and Moon and Jose, Ghost. And thank you for the follow, Morgana. Okay, so we're okay. Anything touching the center bar is counted. Correct! Anything touching this horizontal bar is going to be counted. So notice these ones are not counted, so they're not touching. So if we did 0, this would be 240. Just like how we write 240. And then we have our dots. Dot 87. Yeah. If the, just like how we write, if the 0 happens in the middle, we have to count it. If the 0 happens in the front, we don't have to count it. Kind of makes sense, right? Just like how we write. Like we don't say 002 unless we had a dot, but yeah. Yeah, makes sense? All right. Okie dokie. Oh, that's not what I want. Okay. What else? We are going to take that out and then take this out. Maybe I could print now. So download and then download. Okay, cool. So what are we okay? Are we okay? Should we do another number? Do you want to do another number? Or are we going to continue on with adding and subtracting? Yes. All right. Yes, 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 and yes. Okay, cool. So let's do this number. This we're gonna still deem this as ones. So I will do. Okay, what number is that? I'm gonna cover this so that it's not so. Maybe I should do this. There, there. Yes, yes, Moon. Because it's, yes, good. Welcome, welcome, yes. Right? Easy. Simple to use, easy to understand. Right? Make sense? Cool. Cool, cool, cool. All right. So, what are we doing? We're okay? Okay. Good. Makes sense, right? Easy. Anybody have questions? Because we're going to continue on. We're going to do some adding. We're going to do some adding. Okay. So, the first thing we're going to do, okay, we're going to do some adding. It'll be simple. It will be simple. So, here's my book. And through here, we're going to, I just learned Abacus with you. Just learned Abacus with you in 10 minutes. Yeah, right. Yes, thank you. I never knew how to add. Yes. Yes, that's what I'm saying. Simple to use, easy to understand. So the first thing we're going to do is we're going to understand these are simple numbers. Now, why are we doing it? Because I just want to make sure we understand how the beads move. The reason why that the questions are easy is so we can understand how the beads move. This is not to question your intelligence. This is just to encourage what it would be like and to reinforce that we know how to read the abacus. So here I have 1, so I add my 1. Whoa. And then here I have my other 1. So I'm just going to add my 1. So then my answer is 2. Right? Make sense? So then I'll do this one. Right? This one is, what number is this one? This one's 7. So how do I know? Because I have the top bead here and I have the 2 lower beads here. Right? So 5, 6, 7. And then I'm going to add my 1. Notice that when we're adding, we always think about the add-in and not the result. We're not focused on the result. We're focused on the add-in. So here's another question. We have 5, 6, 7, 8. So we have 8 on the abacus and we add 1 more. When we add 1 more, we know that that number's 9. Right? So if you look, we will always have 9 no matter what column we're at. This will be 9, this is 9, this is 9, this is 9, that's 9, this is 9. Right? Does that make sense? So when we look at our abacus, it's easy to see what 9 is because it's all the beads touching the horizontal bar. If I did this, right, when the top beads are not touching the horizontal bar, we know that this is always going to be 4 because, there's no beads touching anymore. So we know that this is 4. Now, the question is, after we do that, well, the next one we do is we focus on what the 2 is. Why? Because again, it's just to understand for, how the beads move. So if I did this one, let me move that. If I did this one and I'm over here, I'm going to do 5. So I add my 5 and then I add my 2. So I'm going to add 2. Easy, right? This is what we call simple. The equations are simple. No, the addition is simple because we do not use the formulas. Yes, thank you. Thank you, Jose. Exactly. So if I did this one, right? If I did this one, I have 6 and then I want to plus 2. I'm adding 2. What number is that? Oh my gosh, thank you so much for the rose and thank you so much for the heart and the finger heart and the heart me. Thank you so much, everybody. Yeah, right? Ghost is, yes, correct. Sweet treat, yes, exactly. Yes, Melinda. Because why? Because what we're doing is we're just moving the beads. So these are the 2 beads that we're moving, right? Okay, so we're good with this. And that was the one thing is like in regular school, we're teaching the kids to focus on the result. But in Abacus, we actually focus in, yes, yo soy trash. Why not 800? Why not 800? Because I deem this one as the ones place. And you know what? That's a really good question. So here, if you notice, I actually have a dot. This dot indicates you didn't use your... Yeah, you know! I didn't use my thumb and I should have. I'm just being lazy now. Shantoria. So, Skinny Love, the reason why this is not 800, because I said that this was going to be my ones. So if this is my ones, then I have my tenths and then I have my hundredths. Make sense? So it all depends on where we deemed as our ones. So I could have did the ones over here, but I decided to do the ones over here. You could do it over here on this side of the column, like this side of the abacus, but then it might get confusing because, you know, if I decide to like go get up and get a drink of water and come back, I wouldn't remember where my numbers were, because this is right now, it's simple, but when you get more, okay, good. Yeah. When you get more like numbers and stuff and you start working the abacus, it will get confusing really quick. So that's why I would use the indicator to help me keep track. So now we're on 4. 4 is super easy. Why is 4 easy? Because there's only so many questions you could use. So many questions you can have. So here's my question, right? We have 5 and then we add 4, right? And it's all of the beads like that. Ha ha ha! That's a good one. Thank you for letting me know that you guys are keeping track with my finger movements. So the finger movements is also very critical because it adds muscle memory for the children. It's also muscle memory for the adults too. But yeah, it's the muscle memory to do the index finger to do the top, and then the thumb to go up, and then the finger to go down. So remember now, so when we add, we will know how to subtract. So in the book, we just added, now we're going to subtract because we want to be balanced. It's like being Zen. We have to balance, right? We have to balance when we add. Now, why is this? It's not difficult to subtract because the children will know that when they look at this question, this is 2. Now, when we take away 1, we remove the 1. I have to go to sleep, but I love your live. Oh, okay, go to sleep. I'll tune in when you go live again. You know, yeah, I'm always live. I'm always live. No, this is not going to be the last time. So when thank you so much for joining me, Jose. What about the bigger numbers? What about the bigger numbers? Let me finish my thought. So here is, we're going to subtract. When we subtract, we take away from the horizontal bar, just like that. Now, why do we do that? Because when we add, we're adding to the bar. When we subtract, we take away from the bar. Hey, Christian. Does that make sense? Christian? Is that Christian? Like Christian? I just opened the app to your live. I'm learning so much. Thanks for sharing. Yeah, not a problem. Is this Christian? Like Christian? Is that Totoro? Oh my God, you found me. Jay, you're here. Christian. Okay. So going back to understanding the subtraction. So when we add, right, we have 2, and when we subtract, we're taking it away. Right. So yes, exactly. Okay, have a good night, and I will see you later. I'll catch you on my next live. I'm always live. Okay, so there's 2. So yes, when we pull away from the horizontal bar, because if we look, this is 5. We're counted as 5, but now what we're going to do is we're going to move it up. So that means we're subtracting the 5. Yeah, Christian. So we have 6, and when I want to take away the 5, I move the bead up. If I have 6 and I take away the 1, I move this bead down. So it all depends on which bead we're trying to do. The 5 is a little bit more special, gifted, different, because it's at the top bead. And it all depends on our horizontal bar. When the beads are touching the horizontal bar, then it's being counted. Make sense? So we are going to continue on. Okay, so that's what adding. That's what subtraction is, right? It's the same thing here. So we have 2, we have 3. 1, 2, 3. We have 3. So then what we're going to do is we're going to take away 2. We're going to take away 2. All we got to do is take away these 2 beads. That's all I got to do. How do you show 1 minus 5? Okay, So one thing, super interesting. Thank you for sharing. Yeah, not a problem, wiggly hair. Okay, Ghost. The one problem, not problem. The one thing that we need to do is, it's getting hot in here. Okay, super interesting. Um, what we need to do is we need to understand how to make a 5. The reason why to make a 5 is because we need to utilize the top bead. Now that's the one thing that we're going to start doing because we did simple adding and subtracting, meaning that we just moved the beads, right? That's what we just did. We only just moved the beads, right? You could do -2, you can do -3, -4, -5, +5, +6, and so forth, right? So we understand that, right? These are just moving beads. So if I look at this one, we have 8. So this is my 8, and I take away 6. Notice I just move the beads like this, and that's my 6. So my answer is 2. Okay, now to the question 5 minus 1. 5 minus 1, the first thing we need to do is understand how do we make a 5. So in the comment, which pairs to make a 5? What pair of numbers do we need to make a 5? This is a concept that we're teaching the children. This is the concept we're teaching the children to how to make a 5. So the first thing we need to understand is how do we make a 5? What 2 pairs do we need to add to make a 5? Yes, Jasmine. 4 plus 1 is equal to 5. What else? What else do we have? We have 2 plus 3 is equal to 5. Exactly. And then exactly. Melinda, it's 3 plus 2, and then the other way. Yes. 1 plus 4. So this is how we make a 5. Now, why do we want to learn how to make a 5? What we're going to use is we're actually going to, so in school, this is where they stop. This is where they stop teaching. This is all they do. They just teach the kids how to make a 5. But in Abacus, what we're going to do is we're going to utilize, and we're going to understand how to make it work for us, because we're going to put it to work. So what does that mean? Well, what we're going to do is, the question was -1. So what we're going to do, let's go adding and then subtracting. DG Joe products, you could do that, but in school we don't do -1 plus 6. You could. I think it's a little bit different, but that's a good one. I didn't think about that. -1. I'm going to write it down. -1 plus 6. You could, but that's not a pair. The one of the pairs would be this one. This is a fundamental pair that we're going to be working with. So what are we doing is we're going to isolate the variable. To isolate the variable, we're going to use this 1 right here, because the question is 5 minus 1. Now, the first thing we're going to do is 4 plus 5. The first thing we're going to do is 4 plus 5, and then we could do the reverse. So what does that mean? Well, what we're going to do is we're going to isolate this 1. To isolate the 1, we're going to move this 4 to this side of the equation. When we move it to that side of the equation, it will be plus the 1 is equal to plus the 5 minus 4. Now to do plus 4. Plus 5, no, sorry. Plus 1 is equal to plus 5 minus 4. So this is the formula that we're going to use. But now the question is -1. To do minus, we do the reverse. -1 is equal to minus the 5 plus the 4. What does that look like? So if I look at the 5 and I want to take away the 1, my formula says minus the 5 and I add the 4. So this is a little bit more advanced. So we went from simple to making a 5, but then we went to making a 5 to taking away a 5. Taking away a 5 is a little bit more complex. Does that make sense? So, I mean, we can continue on. We can do another one. Let's do another one. Let's do something a little bit easier. Let's do 3 plus 4. 3 plus 4. Notice we do 3. There's not enough beads to plus the 4. So what do we do? When we plus the 4, what are we going to do? We're going to isolate this variable. To isolate the variable, we take the -1 and we move it to the other side. So we have 4 is equal to plus 5 minus 1. So now I have 3. I need to add the 4. I'm going to substitute this equation into here. So what we're going to do is we're going to plus the 5 and take away the 1. So then my answer is 7. Did that make sense? Right? Makes sense, right? It's easy, simple to use, easy to understand. Yeah. So and I know I have to like take it a little bit slower. So let's do another one. Let's do another one, right? So we know the basics, we know the foundation. Let's do another one. 2 plus 4, right? Easy. We could do it in our head, not a problem. But how do you do it on the abacus? Well, it's the same thing. 2, and then I want to add the 4. There's not enough beats to add the 4. Are we adding negative numbers? Is it negative? Yeah, I guess so. I mean, it could be negative, but for us in abacus, we're just reminded to take away. So we don't necessarily call it as we don't necessarily call it as take we don't necessarily call it as a negative number, right? Hi Leslie, welcome. How's it going? How's it going? Oh my God, there's 41 people here. Okay, so we're still back to here, right? So we know what this formula is. We know the formula because we've learned it. We've learned it, and that's one of the fundamentals. Hey, RS, hello. We learned our fundamental. Our fundamental is plus the 5 minus the 1. So where you add the 5, and then we take away the 1. So my answer is 6. Hey, Leslie, I'm back from yesterday. Yeah! Bring down the 5 and minus 1. Yes, Jasmine, right? Makes sense, right? So my answer is 6. Yeah. Jose the panda was here. He had to go to sleep. So, so does that make sense? Yeah, exactly, Jasmine. Thank you so much. Can't wait to catch up on division. I'll wait. Okay. I think we're going to be going pretty soon. Thank you for the follow, Ghost. Okay, so does that make sense? Are we okay? So why the 5th column? Why the 5th column? Oh, why? Because my indicator. So my indicator is here. This is my ones place. I deemed this as 1. Miss Lynette, I have a little person watching with... Yeah! Hi! I need to learn the formula. I still need to learn the formula. Oh, Christian. Okay, so, Jay with your little person. We're going to count. 1, I don't know how old. 2, 3, 4, 5, 6, 7, 8, 9. And then we have 10. This is 10. So DG Joe products, did that make sense? The reason why I did this one, the 5th column, was because I have my indicator. This indicator tells me that this is my ones place. So my ones, my tens, my hundreds, my thousands, and my 10,000. Yeah? And so then, because this is my ones, I can call this as my tenths and my hundredths. So we can do decimals here as well. Yeah. Yeah. Simple to use. Easy to understand. How do you do 7 plus 4? Let me find some new paper. Okay. Now, the one thing that we're trying to understand is I'm using my kids' old books that... Sorry, trying to find a page. Because they use all these books, but they never finish it. So, they never complete the books. And I'm going to do it. I'm going to complete their books for them. Okay, so the question is 7 plus 4. 7 plus 4. Now, we have on the abacus, we're going to do 7. Not a problem, right? Yes. Let's see. Plus 4 plus the 5. Yes, Gina, exactly. So we know, but wait. Plus 4, we know how to plus the 5, not a problem. But the thing is, we need to plus the 10. Why? Because there's not enough beats to plus the 4. Since there's not enough beats to plus the 4, we cannot use the 5 because we're already doing it. Right? We're already doing the 5. So the next one we need to understand is how to make a 10. So we have 4 plus 6 is equal to 10. So now I didn't see how we do 1 minus 5. We don't do 1 minus 5. We do 5 minus 1. That's what we're going to do. But here, so now we're going to isolate the variable. We move this 6 over here. Exactly, Leslie, exactly. So what we're going to do is we're going to rewrite it. Plus the 4 is equal to plus the 10 minus 6. What does plus 10 mean? Plus 10 only means to go to the next column. That's all that it means. All it does is just says, I want to add the 10. I only want to add 1 in the tens column. That's all I'm going to do. So I'm going to add the 1 over here. And then what do? I have to take away the 6. Because that's what the formula says. Take away the 6. So I'm going to take away the 6. So my answer is 11. I didn't, yeah. So Matt, we didn't do 5. We didn't do 1 minus 5. We did it the other way. So did that make sense, Demi? Demi? Yeah? Thank you, Leslie. Somebody's been paying attention. Oh, yeah. Yeah. So the difference is now we have to know 2 sets of formulas. One, how to make a 5, which is what we just did, right? 4 and 1 is equal to 5. 2 and 3 is equal to 5. Then the next step we need to do is we need to know our tens. 9 plus 10 and then 8 and so forth. These are all the tens that we need to do. We need to memorize this. When we memorize this, then everything is golden. So the question is why do you do the thousands column? Oh, because I said that I was going to choose this dot to be my ones. That's why. So is the blue bead a 50? That's correct. So if I did 50, this would be what 50 is. So my favorite subject is math. My mom is a math teacher in Mexico. Oh, that's cool. Did she learn how to use the abacus too or no? Miss Lynn, I figured out I could use the target counting tool as a reckon rack. Yes, that's what I was thinking. You could use it as a reckon rack. You could start grouping the 5s as well if you wanted to. So Demi, the blue bead is 5. Yes, Leslie Garcia was correct. Yes. No, she didn't. Oh, okay, no worries. So yeah, it's interesting. I wonder like what other techniques were being taught in like other countries. So that'd be really interesting to know. I wonder like how much does the abacus align to other countries? That would be the other thing. So um yeah, so Jay, for the target counting one, you could group the 5 together. So you only and then like the Chinese abacus, right? Group it together to make a 5. You could do that. And then and that would be it. Ask her if she knows. Yeah, right? Yeah, your patience keeps me here and happy. Yeah, happy. Yeah, there's no harm in asking questions because it's more difficult to follow if you don't understand or if you don't get your answers if you don't get your questions answered like it's supposed to. You know what I mean? So, yeah, the white and the red. Yeah, I don't know if Jay, if you want to tape it together so you have this as a 5. That's what I'm thinking. What's the difference between the two? Yeah. So this one is a Chinese abacus. Why does yeah, I don't know why, but it started the Chinese abacus was first and they did it from 10 columns and then they made it more efficient and now they did it in the 5 bead on top and the 5 beads on the bottom. But then I can tape. Yeah. And then tape, I would tape it so then you get the full effect of moving the 5 and then you could do the formulas. You just have to ignore the bottom, you just have to ignore the last bead. So the difference between this is the Chinese abacus and the Japanese abacus. The Chinese abacus started first, and then what does Japanese people do is they make everything more efficient and then they made this. So the Chinese abacus is a little redundant. We can count it. So we do 1, 2, 3, 4. 1, 2, 3, 4. Right, just like on the Chinese abacus and the Japanese abacus. But notice 5 will always be this no matter what. In the Chinese abacus, this is 5. or this is 5. Now, the problem with this is I have 2 things to remember what is 5, and that's too much for my brain. I'm just saying. I will do that. For the question of why is different, I'm sorry. Yes, I will do that. For the question of why is it different, my answer is probably due to evolution. Yes, it is due to evolution. It is due to evolution, but it's also depending on like how young your child is, and it's still just as good because then you could see all of the blocks together. Yeah. So then we have 5. So this is 5 or this is 5, not a problem. But then that's 6, right? Again, it's the same thing. That's 6. 7, 7, 8, 8, 9, 9, and then now we have 10. So on the Japanese abacus, we have 10. This will always be 10 and no matter what. And it's cool because we can use our place value. Our place value tells me that this is the ones, this is the tens. The problem that I see with the Chinese abacus is that now this is 10. But wait a minute, I thought we were doing place values. Well, that's where the logic kind of goes out the window. So this is 10 or this is 10. Can you solve algebra with this? No, you cannot solve algebra with this. This is the stepping stone to algebra. So we learned our formulas. We will learn the framework, and we substituted formulas, and we substituted and we isolated the variables. Those are the beginning parts of algebra. So Abacus lays the groundwork of what algebra can do. And so what Abacus does, it lays a foundation to have a solid understanding of what numbers and number fluency is, and flexibility, and all those crazy high-tech math terms. And then when you have a solid foundation on Abacus, you can go into more complex math, because Abacus is the gateway to complex math. That's all it is. The abacus is not the end all. We don't do sine, cosine. We don't do any of the calculus. What we do, I have to go to bed. Yeah, go to bed. Yes, you can multiply. I have to learn so much. Oh yeah, Ghost, have a good night, and I hope to see you in my next life. So yeah, so abacus is the foundation. It is just to lay the groundwork, right? Just like you have baking a cake, right? You have your stuff. Like you have your eggs and you have your flour. This is the base, this is the foundation, this is the thing that glues everything together. And then you can add the icing. Then you can add the fruit on top of your cake. Then you can add like sprinkles on top of your cake, right? So that's the difference. What we do is Abacus does the foundation just to give you a solid and fills the gap. And then from there you can go into more complex math. So, back to here, this is 10. How do I know? 5 plus 5 is 10. Then this is also 10. So now in Chinese abacus, we have 3 ways to do 10. And that's too confusing for me. I'm a simpleton. That's too much for me. So on the Japanese abacus, it makes sense that this is a 10. This will always be a 10. But now with the Chinese abacus, I have 3 ways to do 10. That's 10, this is 10, or that's 10. And I'm like, you know what? Woo, that's too much. So that's the difference between the two. And that's exactly right. It's the evolution. And I think this is as far as it goes. I can't see it getting any better than this. So we're learning how to read the abacus. That is a little bit about some history of Chinese abacus, and then understanding how we do the adding of the 5, making of the 5, and making of the 10. So, first time watching, I've learned a little bit more. Can you show us multiplication? I can show you multiplication. Are we ready? Are we ready? Okay, so let's do one of the simple ones. There was a simple one that we did yesterday, and I was like, ooh, that's a good one. I got to keep that in my tool belt. Oh, is this one? Okay. We do this one. Let's do some multiplication. We're ready. We're ready. People are ready for multiplication. Okay, so we're going to do 34 times that by 7. We're going to start with that first. Oh, that's dark. That's so dark. Okay, what are we going to do? The first thing we're going to do is we're going to find our starting point. Why? Because we need to know where to put the answer on the abacus. So to do the answer, thank you so much for the hearts. Wow, I got 10,000 hearts. You guys are great. Yes. So how did Leslie do it? Well, what she did is she counted 1, 2, 3. We need to count the digits that we have in our question. So what we're going to do is we're going to start from here and we're going to count 1, 2, 3, right? So then what are we going to do? What we're going to do first is we're going to do 7 times 3 first. 7 times 3 is equal to 21. So when we do 21, I'm not going to say, so that's the other thing. I'm not going to say 7 times 30. You could, but the reason why we do it on the abacus is so then I don't need to do it, right? We're going to utilize the abacus for what it is. And what it does is it helps keep track of our digits. So I would not say 7 times 30. What I would say is 7 times 3, and my finger is here. So I'm going to add the 20, I'm going to add the 1. And then finally, 7, because now I'm here, 7 times 4 is equal to 28. So again, I do 20 and I do 8. So I add my 20 and I add my 8. And that is multiplication. So my answer is, please tell me in the chat what my answer is. And I'm going to go find another question. No, I didn't want that one. So, what is that answer? This is so useful. Oh, yeah. Oh, good. I'm happy that it's useful. The answer is, thank you, Nancy. Thank you, Leslie. 238. Exactly. So using it for algebra makes it visual. Yes, using it for algebra, yeah. To do the calculations in algebra, you could. Would I recommend it? I don't do algebra. Honestly, I can't. You could try. I'm not gonna stop you. You could try. Yeah. Okay. Thank you for the follow. Your saved sister. Okay. So that is. Are we ready for a 2-digit multiplication? I was top of my class in school, 98%. That's great, Nancy. Do we want to do 2-digit multiplication now? We can do 2-digit. It might be a little bit more complex. Can you do another one like this? Yes, I will do. Okay, I will do another one like this. So, okay, this will be easy. This will be easy. We'll do fives, right? 5 is easy. 94 times that by 5. Now, one of the questions is like, can you do 2 times 4? No. Why? Because this is a math fact. What we could do with this is we would have to do 2 plus 2 plus 2 plus 2. So you could do cumulative. Yeah, not just 99. Leslie. Yeah. So when we do the math fact, the idea of the math fact is just to make sure that we understand that we have to memorize. We have to memorize our math fact. If you don't want to memorize it, then you would have to do cumulative, and then it would get complicated fast. Or you can do the other way, right? The other way is 4 plus 4, right? So that's the one thing. That's the one caveat when we do multiplication on the abacus is that you kind of need to know your multiplication fact. So we're going to here, it's 3. 1, 2, 3. I'm going to put my finger here and I'm going to move the question up because I keep moving my paper. So the first thing we're going to do is 5 times 9, right? So 5 times 9 is 45. I add my 40 and then I add my 5. Exactly. Thank you, user 6636. I just see your numbers. I don't see your name yet. Okay, so 45. So I'm going to keep my finger here because that's where I last ended. So what's my next one? My next one is 5 times 4. 5 times 4 is 20. So all I have to do is I add 20. 2 and a 0. I add 2 and I add a 0. So my answer is, what is my answer? Exactly. 470. Thank you. Thank you, Leslie. Thank you, Nancy. Yes. 470. Oh, my camera. There we go. That's better. That's better. Yes. Did it make sense? Yeah. Cool. We can do another one. We do another one. Let's do another one. This one seems to be a better one. Okay. So, let's see. Let's do this. Let's do our 9 times table. How do we do about 9 times table? 72 times that by 9. So again, oh, thank you. I'm amazing. Thank you for taking the time to teach us. Yeah, not a problem. Hey, Rena. New here. Hi. We're talking about the abacus. So, before we continue, before we continue, Raina, this is how we count on the abacus. 1, 2, 3, 4, and then 5. So all the top beat is 5, and then we add 6. How do I know? 5, 6. So this is 6. Anytime the beads are touching the horizontal bar, this is the horizontal bar. Thank you, user 6636. This is a horizontal bar. So we have 6, 7, 8, 9. So we will do, okay, Demi, we will do, let me write that down. 45 times up by 67. Okay, so the first thing we're going to do is we're going to do 9 times 7, right? 9 times 7 is 63, which is good. 63. 63. So we're starting here. We have 60, and then we have 3. And then again, we do 18, right? How do I know? Well, then I got to move. So 9 times 2 is equal to 18. So I add my 1, and then I add my 8. That's 8. Yeah? So we know my answer. What's my answer? Answer is 648. Yes, thank you. 648. Okay, so, the question is this. What are we doing? The first thing we need to do is our starting point. What is our starting point? What's our starting point? This is the question we're looking at. The thousands. Yes. Shantoria. Yes. 4. 1, 2, 3, 4. How do I know? Because I'm counting all my digits. Starting point is the 3rd bead. To the left, and it's the 4th bead. Because it's 1, 2, 3, 4. Yeah. The answer at the end. 1, 2, 3, 4. We're doing double digits. Yeah, it's this one. This is the one we're doing. Okay, you know what? I'm going to rewrite. 4567. Let's do this. 4567. Let's redo that. You know what? I'm going to move this out. Okay, so 45 times that by 67. Okay, so I clear it. 1, 2, 3, 4. Okay, so the first thing we're going to do is we will take the 6 and we're going to times the 4. That's what we're going to do, because that's what we're going to do. So 6 times 4 is equal to 24. So I add 2 and I add 4. I'm still here. So next I do 6 times 5. 6 times 5 is 30. Do we remember our making of the 5 formula? I want to add 3. There's not enough beads to add the 3. So what do I do? Yes. Plus 5 minus 2. That did not work. You're right. So we're going to plus the 5. and then take away the 2. And then I have my 0, right? That's the 3. Okay, the blue bead, 2 rainbow. The blue bead, yeah. So now I'm done with the 6. I need to reassess where my next placement is. So what we're doing is we're doing long multiplication. So now we're doing partial products. Because we're doing partial product, now we have to reassess where we're going to go. We have how many left? 1, 2, 3. So I'm going to start 1, 2, 3. Now the question is 7 times 4. 7 times 4 is equal to, yes, Gina. 7 times 4 and then, yes, Nancy. 7 times 4 and then 7 times 5. Yes, thank you, user. It's 28. So we have 2, we add our 20, and then over here we're going to add our 8. And then 7 times 5 is equal to, 7 times 5 is equal to 35. Yeah. Okay. Okay. This is going to be a little much. Why? Because I already foresee that we have a two-step equation. Two-step equation is also a common algebra methodology. Algebra? Is it a methodology? It's a two-step equation. I just need to say that. It's a two-step equation. Algebra has two-step equations. Abacus has two-step equations. So before I continue, I'm going to change my marker so we can keep track. I need to change my marker. Okay, so what are we doing? We're adding a 3. We need to add 35. Now, if you look, there's not enough to add the 3. So what do? I have to plus the 5. Can't do it. So what's my next one? Plus 3 is equal to plus the 10 minus 7. Two-step equation meaning the method we use to break down each digit. Yes. Meaning, yes, exactly. Because what Abacus does is it breaks down and it decomposes to the smallest number possible. So my 3, I cannot. So I have to plus the 10 minus the 7. Plus the 10, I cannot. So what do? Minus the, plus the 1 is equal to plus the 10 minus 9. So I'm going to substitute this into here. Let me rewrite the whole thing. So what we're going to do is we're going to do plus the 10 minus the 9 minus the 7. So if I line it up, let me see if I line it up like that. If I line it up like that, right? What am I going to do? I'm going to plus the 10 minus the 9 minus the 7. This is all because I need to minus the plus the 3. That is the only reason why. Right? So what I'm going to do, I'm going to plus the 10, I'm going to minus the 9, and I'm going to minus the 7. That's the 3. Now I add the 5. I go over here and I add my 5. That's it. Did that make sense? Yeah. Right? Yeah, right? Yeah, I think what I need to do more is explain it this way. So then you could see where I'm going to take away the columns. Right? But don't forget, this is also formulas that we need to know. These are formulas you need to memorize. Before you get to multiplication, division, you need to memorize your formulas. This is hands down. You need to know how to make a 5 and how to make a 10. If you know how to make a 5 and make a 10, then everything is golden. Everything is golden. Then everything else is just like gravy on top. But this is the reason why you need to know how to make a 10 and how to make a 5 and how they all kind of like all the different scenarios on making a 10 and making a 5, because it depends on how everything is and you just kind of like move everything together. So let's do something more simple. Let's do something more simple. What does that mean? So let's add 49 plus 3, right? 49 plus 3. Well, that's easy. Well, this is where the two-step equation. So when we start talking about adding and subtracting, we actually slowly introduce the different numbers because different numbers have a different way of seeing things. So we have 40 and we have 9, right? We have 40 and 9. Now we're going to add the 3. This is where the two-step equation is. Why? Because there's not enough beads to add the 3. What are we going to do? Again, we need to plus the 10 minus the 7. So when I plus the 3, it's equal to plus the 10 minus the 7. Notice I don't have enough beads to plus the 10, right? I don't have enough beads to plus the 10. What am I going to do? What am I going to do? Well, if I want to add 10, if I want to add the 1, I can use the 5. So what am I going to do? It's plus 5 minus 4 plus or minus 7. So I'm right here. I'm going to minus the 7. So I'm going to plus the 5 minus the 4 and then take away the 7. And that's it. My kid's having nightmares. Catch you later. Oh, yeah. Have a good night. Yeah, not a problem. I'm always on live, so I'll catch you in the next. I'll catch you the next time. Yeah. Sorry. Hopefully they're not having nightmares on math. Do you mean 40? Yes, I do mean 5 minus 40, but I don't want to say 50 minus 40 because the abacus will already keep track. I just need to know the the base numbers. So when we talk, I don't say 6 times 40, right? I say 6 times 4. So we want to do is we want to just have the simplest form of the equation. We're having Super Mario Day movie and listening to how you teach. Jay, that's funny. So does that make sense, user 653? Because we don't want to it'd get too complicated if we had to keep track of our zeros when we write. So that's why we keep track of it here. We don't need to say 40 because I see it here. I just need to add the 5 and then minus the 4. So that's what that means. Yeah. Oh my God, I can't believe I've been here for already an hour. Okay. Okay. There's still a lot of people here. You guys are so crazy. We're mathing in the middle of the night. Well, most of you guys are in the middle of the night. Okay. So, does that make sense? We can go further. We can do division if we're ready for it, or we can continue on with multiplication. But yeah, for meaning of 50 minus 40, you'd get complicated really quick. Because why? Because let's say it's 500, right? Then we're going to be 500. So let's do 490, right? Division. Okay, we'll do division. Division decimals. Hold on just a minute. So here, the question is 490. 490, right? 490. We're not going to say, so we have add 30. We have it in the question to add 30, not a problem, right? But when we talk about it, we're not going to say plus the 30. What we're going to say is we're going to say plus the 3. Does that make sense? So what we're going to say, we're going to say plus the 3 minus the 10. We don't say plus the 30 minus the 100 or plus the 100. So when we talk about the formula, plus the 3 is equal to plus the 10 minus 7, we're not going to say plus 30 equals plus 100 minus 70 because then you just make it more complicated than it really is. It's just like we don't do multiplication higher than 9. Like we don't memorize 10 times 9, and we don't memorize 11 times 7, and we don't memorize 12 times 6. We don't memorize that. We use the simplest form. Yes, exactly. We use the simplest form because Abacus keeps track of our numbers. So when we're taking away 30, We don't say take away 30. We say we take away 3. But we need to know it's 30. 3, 0. The 0 is here. The 3 is over here. So when we do, it's plus the 10 minus the 7. So we plus the 10 because the 10 just means to go to the column, to the next column. And then we minus the 7. Yeah. Yeah, exactly. The 3 is already in the tens place. So now we didn't need to be, we don't need to be redundant when we say minus 30. So that's why we don't say, that's why we do not say 50 minus 40. Because it's just too complicated. Not complicated, but you're overthinking it, right? Because we're not writing it. We're looking at it on the abacus. That's the difference. You look it on the abacus and you embrace the abacusness of the beads. Embrace the beads. Let it do what it's supposed to do. It will keep track of the place values for you because the 5 is already there in the tens place. Exactly. But what it is utilize the tool for what it is. It will tell you and you'll keep track of your place values. All right. So we're going to do division. I'm going to make another page. All right. This one is our tower challenge. Okay. Let's see. Oh, I can do it here. Okay. We're not going to do decimals just yet. I mean, decimals is the same thing. We just need to, let's see. I got to go. Okay, let's do something simple. So decimals, we'll do something simple right now. 128, divide that by 2. And then after this, we can go into decimals. That wouldn't be a problem. But we just have to figure out when we cut it off. Okay. I'm going to use this one. I got to use this one because I don't know how big the number is. I'm teaching my little human the place value. Yeah. Good. I'm teaching my little human the place value system. Yeah. Okay. So what we're going to do is just like when we do multiplication, we need to figure out where we're going to put our answer. To figure out how to put our answer, it's the same thing. But this time, because multiplication, we added the digits. Division, we take away the digits. Thank you for the follow. Everybody. So what does that mean? Well, 2 take away 1 digit, take away 3 digits. Thank you for the follow, EP. Welcome. So because we're taking away the 1 digit and then these are 3 digits, what we're going to do is we're going to figure out our place value. 3 take away 1 is equal to 2. So our place value is 2. It could be minus. But yeah, right? 1, 2. So we're over here. Now what? Now we got to put our dividends onto the abacus. So we have 1, 2, 8. Okay, so we put that there, right? So what are we going to do? I am going to label because I am not going to remember what I'm talking about. So here is my divisor, and this is my dividend. So S is divisor, and dividend is an E. We're going to set up the chart. Is that the correct place value? Yes, that is. I'm sorry, Jay. Yes, 2 is the correct place value. So because this is where I'm going to put my answer, I'm going to put my dividends on the other side. So what's going to happen? Now I got to compare. Divisor or dividend. My divisor is 2. My dividend, I'm only going to take this one dividend. That's it. How many columns to the right of the first dot? 2. Just as you said. 2. 1, 2. My first dot is right here. 1, 2. Oh, sorry. Is that better? So this is my 1, this is my 2, and then this is my dividend. These are my dividends. 2, but isn't it the thousands place? We're dividing. When we divide, it's not that way. Because it's 3 digits, take away 1 digit, it gives you 2 digits. We couldn't see what you were writing on the right. Oh, that? Divisor and dividend? Yeah, okay. Let me see if I can... There. Hopefully that's better. Okay. Okay. So, Jay, no, it's not the thousands, it's the tens. Because we count from the dot. This is the dot. This is my ones. So it's just 1 and then 0. I meant on the abacus. We're using the beads that means 100, 1,000. Are you using the beads that means 1,000? No. This is the thousandths. But we're not doing decimals right now. The dots. The dots. No, I think I'm doing the millions. If I go from I'm in the middle. So if I go from here, this is the ones. If I go from here, ones, tens, million, I think. Ones, thousands, million. When I'm in the bigger abacus, I'm in the middle. That's all that means. I'm just in the middle. So I'm using the middle dot. Yeah. Okay, yeah. Okay, yeah. Okay, got it. So, oh, I'm only going to compare the one digit. Why? Because I need to know who is bigger. This will tell me I'm trying to place myself using the dots. I see. I'm trying to... You might want to... I know your abacus is like this. You might want to do this. And be in the middle of your abacus. If that makes sense. And then I would label the middle. I would label the middle as your ones. That's what I would probably do. Yeah. So, yeah, cuz yours is like this. I would change your abacus to be like this, and then I would label the ones. That's what I would do. Okay. So, why are we comparing? Because when we do this, 1, 2, 8, we're not going to see this, right? This is what we're writing. We're doing long division. What we're going to do is, the reason why we have to compare is to see if we're going to do 2 columns or 1 column. So if the divisor is bigger, we know that we cannot just take away 1. We have to utilize 2 columns. So we got it. So when we look at our question, I'm trying to formulate what I'm thinking, because I remember what Dandelion said yesterday. And it made sense to her when I said it. But I have to figure out how to project that, communicate that. So the reason why, so now because 2 cannot take away from 1, we have to utilize 2 columns. So the question is, 2 times what is equal to 12 or less? 2 times 6. So I'm going to add my 6. That's my answer, 6. I'm going to take away 12. Take away 1, and then take away 2. I'm going to put my answer here in long division. So now, I still have dividends. So what do? I compare. My dividend is 8. My divisor is still 2. My 8 is bigger. So that means, I guess I can do that, right? So that means that I can divide 2 into 8. If I do that, I need to, this is a rule. You need to skip this column, right? You need to skip this column, and you're going to sit here. And then you can only use 1 column. Why? Because the dividend is bigger than the divisor. So when we look, it's 2 times what is equal to 8 or less. 2 times 4. I'm going to add my 4, and I take away my 8. Because the whole number is 3 digits, yes. 1, 2, 8, yes. And because the whole is 3 digits, my divisor is 1 digit. I take away my dividend from my divisor. I'm just taking a little break because I know it's a lot. Hello! Hi, RS! Can you do 8 divided by 5? Yeah, that's a fraction. Somebody was talking about fractions. Let's do a fraction. So did this make sense? So my answer is 64. Okay, so I know user, why did you say it's 12 and less and 8 and less? Because sometimes it will be 13, right? So what we're doing is we're trying to find the multiplication fact that closest so we can take away the number. So let's say it would be 2 times what is equal to 13 or less. When we take away, we want to take away the number. I'm still trying to use the process. Yeah. So what about, okay, Demi, we're going to keep this on the table. The question is, how about 127 divided by 2? We could do that too. Let's do that right now. And then, yeah. So you know what, RS, your question will be answered when we go to the next one. So the next question is 127 divided by 2, right? Again, our starting point is 2. Why? Because there's 3 and there's 1. So 3 take away 1 is equal to 2. So our starting point is 2. 1, 2. I'm going to put my dividend 1, 2, 7. Right? Let me rewrite it so we can kind of see. We're going to rewrite it like this. Now the question is, who is bigger, my divisor or my dividend? Right? Divisor is 2. My dividend, I'm only looking at the 1 digit. I only need the 1 digit. I only need to look at this to see if I need to do 2 columns, right? 2 columns, 1, 2, or 1 column. Now the reason why is because you cannot take away 2 from 1. Then you need 2 columns. So that's why I have to compare. 2, who is bigger, 2 or 1? 2 is bigger. So that means I need to use 2 columns. I have to take away these 2 columns. So now the question is what times 2 is equal to 12 or less? I say less because when we get to bigger numbers, it's just good to be part of the vocabulary, part of the rhythm, right? Just like when we sing our alphabets, we sing it like as a song. Okay, so it's 6. So we add 6. That's my answer. We take away 12, take away 1, take away 2. So I still have dividends. What am I doing? Well, I got to continue it on, right? I got to move my abacus away. You say less because we need to use the simplest numbers. I say less because we need to use the answer closest to the number. Because you could say 2 times 3 is equal to 6. 2 times 3 is equal to 6, but that's not the closest number to what we want to get, right? You could say 3, right? And then you have to do 6, right? And then there'd be 6. Then you would have to do it again. So in Abacus, it's very similar to how we do math in mainstream math. Okay, so we're still here. Who is bigger, 7 is my dividend. My divisor is 2. My 7 is bigger. So I'm going to skip one column. I'm only going to take this one column. So this is the prime example of understanding what less means. So 2 times what is equal to 7 or less. 2 times 3 is equal to 6. So I have 3 and I take away 6. Dividends are inside the box, divisor is outside. Yes, divisor is here. Divisor is here. The dividend is here. Okay, so question, who is bigger? I have 1 and I have 2. 2 is bigger. So what does that mean? Well, 1, I'm going to start doing my decimals, right? And 2, I'm here. So this was supposed to be 6. This is 3. So this is my decimal. And now my remainder is 1. But we're going to use 2 columns. So what's the question? 2 times what is equal to 10 or less? 2 times 5 is equal to 10. Take away 1, take away 0. So my answer is 63.5. So there's your decimal. You just keep going until there's no more remainder. If there is a remainder, then you have to figure out where to stop. Yeah. So user 653, it just depends on how far you want your decimals to go. You can go further, but why is the 0.5 on the abacus? Why? Because 2 times 5 is equal to 10. That's why. Let me rewrite it. Let me rewrite it. So the question is 2127, right? That's the question. So we're back to here. 2, right? 1, 2. 1, 2, 7. We did 6, right? Take away 12. We do that, right? So that's 6. And then 7 is bigger, so we're over here. So 2 times 3 is equal to 6. So 3 goes here. Notice I don't have any more, but I have more. I have more dividend. So my 3 goes here. Notice that my 1s and my tenths, now, if you look, I still have dividends. I still have a dividend. I don't know if I need to use 1 column or 2 columns. So what does that mean? Well, I still need to compare. Divisor, yeah, that's my remainder. But can I still divide it out? That's the question. And it depends on how far you want to go. So we could stop here and your remainder would be 1. You could, right? Or you can divide it out and you can have decimals, right? So in this case, I'm going to divide it out. So the question is 1. Who is bigger, 2 or 1? The 2 is bigger. We know if it's 2, we have to use 2 columns. So we have to imagine that there's a 0 there that we're using. So what happens is, the question is 2 times what is equal to 10 or less? Thank you so much for the hearts. So because the divisor is bigger, I'm using 2 columns. The imaginary 0, so we know that 2 times 5 is equal to 10. So I put my 5 in the tenths column, because remember, I've already finished everything here, right? So now anything after the ones is my tenths. So this is where the 1 sits, and I have the 0. So I have my 5, and I take away 10. And there we are. So either you have a remainder, and you state it, or you divide it out. You can keep going. You can divide it till infinity, depending on how big your columns are. So, just like we're going to do the other one, we're going to do the fraction. 8 divided by 8, 8, 8 and 5. That's a fraction, right? Easy. Easy. That's what I'm saying. Using a decimal is not a really big factor for Abacus, because you just gotta divide it out. So, thank you, Sarah Jane, so much for the heart me. I'm just now looking up. Thank you. So let's do this fraction. This is a fraction, right? 8. We can rewrite this. 5 divided by 8. We're going to put our decimal right here. Why? Because I know we're going to need it. So what are we going to do? Well, our dividend is equal to 1 digit. Our divisor is equal to 1 digit. So 1 take away 1 is 0. 0. So our starting point is 0. So if this is ones, my 0 is here. And then I add my 8 here. So what am I going to do? I have to compare. Who is bigger? My dividend is 8. My divisor is 5. My dividend is bigger. So what do? I go here, and I have to only take this one column. So now the question is this is the prime example. What times 5 is equal to 8 or less? 5 times 1. 5 times 1 is equal to 5. So I take away 5. Now what do? I still have dividends. I'm going to divide it out. What is left? 5 is my dividend. 3 is my 5 is my divisor. 3 is my dividend. So what do? Well, my divisor is bigger. So I'm going to take 2 columns. I have to take 2 columns because now I have a remainder. Take 2 columns. So what times 5 is equal to 30 or less? 5 times 6. So I have my 6, and I take away 30. So now my answer is 1.6. And I just did a fraction. Did that make sense? Why is the dividend 2 places to the right? Because we had our question, 1 divisor, 1 digit divisor, take away 1 digit divisor, 1 minus 1 is equal to 0. It gets a little hairy when we have decimals. But because 1 take away 1 is 0, I go to this column to the right. So I would call this as ones. This would be 1, 2, 3, 4, and then after this would be 0. So that's why I would put my dividends here. So my answer is supposed to be here. I put my dividends in the last 2 places. That's why. So it gets a little hairy when we start going into more complex. Thank you for the lightning bolt and the ice cream cone and the heart puff. That's a lot of stuff. Thank you so much. And the rose and the heart me. Ah, yeah, yeah. In division in Abacus, there's set rules. There's more rules to it. It just depends on the numbers, and more. It's just more rules. So when we do division, it's a little bit more complicated because there's a little bit more rules that happen. But we haven't gotten to that point yet. Right now, we're just doing the basics, and that would be the understanding. So, all right, are we okay? We went all the way from adding to reading the abacus all the way to division decimals and fractions. We did fractions. I mean, that's what it is. Really, what a fraction is just it's just that, right? That's a fraction. All right. Thank you so much. I have comp sci homework to do. Okay. See you later, Leslie. It was good to see you. It was good to see you. Thank you so much for joining. Yeah, I think I'm going to sign off. I'm going to sign off. I think it's a lot of math right now. And it's getting late. I think it's time for everybody to go to bed. Go to bed, everybody. So, but yeah. Thank you. Have a good night. Have a good night. Good luck on your comp sci. Yeah, thank you. Thank you for the questions. I do appreciate it. I do appreciate all the comments and the questions and the not understanding because it helps me understand how to communicate that better. I gotta figure out how to make this better. I just gotta figure that out. But I do appreciate letting me practice my communications with you guys. I do appreciate it. Thanks for explaining so far. It was fun. Yeah, not a problem. Not a problem. Yeah. It'll be interesting to see how I can make my workbook now. Because I'm going to make an adult workbook. So, thank you again, everybody. Thank you. Thank you for joining. It's been pretty good. There's a lot of people still here. Thank you, everybody. I do appreciate all the gifts. Thank you, Jay. You're giving me gifts because you don't want me to tease you about your abacus anymore. Thank you for teaching it. Yeah, not a problem, Demi. Not a problem. But yeah, Jay, let me know how you deal with your abacus because I think it's still possible to do what it is. You just gotta finagle it. That's all. Finagle it. You know what? It's to think outside the box, and that's what abacus does. Abacus helps us think outside the box. Oh, all right. All right. If there was no other questions, I am going to sign off. I have so many questions. You don't have that many questions. You don't have a lot of questions. But yeah, it would be interesting to see like if you when you finagled your abacus a little bit. I don't yeah, you wouldn't need to, but I think if you do it that way, your child will have a leg up because they can see the quantity. They can see the quantity of the 5, and I think that would be actually better. That might be a thing. Maybe that's a thing that you need to do. And then make millions of money. So, okay. Okay, have a good night, Demi. And shipwreck. This fried my brain. It is a little much, but don't forget. I mean, we went from 0 to 100, right? So it takes a little bit. I mean, I've been doing abacus for more than 20 years, so this is kind of like, meh. Yeah, not a problem. Not a problem. Thank you so much. Thank you so much for the gifts. But yeah, how old is your little human, Jay? So I can kind of figure out. I don't know if I asked you that. Um, I don't know if you want to tell me. It's fine. You don't. But I mean, I do have worksheets that you could take a look at. Okay, see you later, Demi. I do have worksheets if you want to, um, have your little human work with it. It just depends on some the beginning stuff is kind of easy. My little home is still learning. Oh, you know what? Then you might want to think about doing this one, and then have the little activities, because there's that, and this is available on Amazon. You might want to try that, or you can go to my TPT and take a look at all the worksheets. TPT, if you want to go to TPT, you can see my worksheets that I have. That's why I said I needed that. Oh, ha. Yeah. So, yeah, my TPT is like learning hyphen with Lynette. If you go to the TPT, I have a bunch of worksheets there. That's not all of it. I mean, I'm constantly making worksheets, and so it just depends on like how far along. And, oh, I got one I got one for St. Patrick's Day. I don't know if you wanted to do that, but this one is really just strictly about understanding the numbers. And so this was like a maze. It starts off with understanding like the frame. So this is number 2. It starts from 1. It starts from 0, and then there's the 5 frame, and then this is the idea that there's nothing there. There's the empty abacus, and then there's tracing. So because there's tracing, then they can keep tracing, and then they can color it in. So the idea was to get it to like the motor skills, and it goes all the way to, what number does it go to? It goes to 9, I think. I think I did only to 9. And then, oh no, I go to 10. I go to 10, but I try to make it a little bit simple and then have them to trace the circle. So this is the 2 columns, right? The idea. And then have them trace the number, trace the word. This is supposed to count how many digits, how many items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this was the pixel art. The pixel art was color in the box, and then find the answer, or find the number in this pixel art. So this is a 0, so they find 0. This is a 1, they find all the ones, right? So it was more like that. And then, here was the idea of seeing the words. And then this one was color by number. And again, this is 3, so they would have to find 3 somewhere around here. And then I did 5 and 7. So this was a lot of just bead and number recognition. And there's some cutting involved. I have it where they were doing some cutting. And then, oh, I didn't do this one. That's not it. Cutting. Where's the cutting? I don't think I added it. No, it's in here. No, that's not it. Here. So this was, what it was is just find the pattern. And, you can print it in color and stuff. Yeah. So that's what I have. That's the St. Patrick one. This is and then this one, this is a maze. So the maze is to count forward. Or is it looking for, no, sorry. This is to look for the number 5. So you start from the leprechaun and you find the number 5. So you start from the leprechaun, is this the 5 or this is 5? This is the 5. So you color that in and you just keep finding the 5. So there's 5 here, 5 here, 5 here. So this is not 5, so you want to go here. So that was the one thing. So that's that one. And then again, this was just bead and number recognition. Yeah. So that's an activity. There's another one. I did Easter, where it's again just number recognition and understanding how to sort. So it was a lot of sorting problems that I had. Sorting worksheets, and I like them because I wanted to cut. Oh, I see. I was wondering what those drawings meant. Oh, yeah. These ones? These ones? So the idea was to trace. So this is 8, right? Yeah. So this is the abacus. This is the column, and then here is the horizontal bar. And the idea was just to get them to trace and then get them to color. Because the thing is to know the difference between the picture and the actual abacus. So ideally, you would have your abacus as well as the picture to show that there's a 1-to-1, to show the concrete to the representation. It's the same thing when we have these. These are what we call representation. 1, 2, 3, 4, 5, 6, 7, 8. So that was my thought process. The reason why, because I wanted them to see the abacus and also see the items, but also see it on the abacus. Because there's not a lot of worksheets that deals with concrete manipulatives. And so when I was trying to abacify kindergarten worksheets or preschool worksheets, I wanted to make sure that it was still being introduced. So that was the reason why. So that, and then having said that, I mean, that's the reason why I started making this one, where this is the adult version, and I have it a little bit more complex. Abacus-2025. Yeah, right. I'm gonna Abacus-2025. I'm modern. There was many things I was saying. I'm modernizing Abacus, or I want to popularize Abacus. And so one of the things was to create workbooks and worksheets so then it can be used. So this one was my adult version to read the abacus. And so they can start learning how to read the abacus. I added more though, like the ones indicator. So there's a little dot here. And then this is where there's more. And then I also have the decimals. So in the adult workbook, there will be thousands and decimals. But then if you do the preschool, the next one after this would be the +5. If depending on how quickly they understand it and you want more practice, ideally after the preschool one is the +5. If you need more practice and you're okay with it being themed and you want it as a book, I do have the Halloween one. Or if you want to, you could do this one, which was kind of cool. And it was just this is just a regular coloring book, and so it was the same thing, right? They just color it in, and they can be creative. And this is just talking about like the 1, 2, and I was trying to be a little bit creative. I haven't worked in it in a while, but I want to finish this book. And it goes to this. How do you draw the arrow to signify the dot? I like how you draw the arrow. Oh, to signify the dot. Yeah, but that's only for the adult version. I don't do that for the kid version because we wouldn't worry about that just yet. But thank you. I appreciate that. There's going to be like exercises on how to read the abacus. So, yeah. So there's the if you wanted to do a coloring book. So I'm working on my 7th workbook. But I do need to make more, just to get it out there. I do have a lot of worksheets that still runs through my head. So, if you have any other questions, yeah. Oh yeah. So I think that's it. I think that's all the way I have. Oh, I just have to put it all together. I just gotta put it all together and I just gotta put it all together. That's all. Yeah, because through my books, my students go through my books, and so I have there's a whole curriculum. It just depends on how fast or how slow it is. So, yeah. Just a thought. All right. Thank you so much for the hearts. Hey, Chef. You're back. I see Chef sometimes. I don't know if it's the same chef, but I'm thinking it's the same chef. So, any more questions? If not, I am going to sign off. We did do a lot today. We did do a lot. We did a lot today. Is there any other questions? If not, I'm going to sign off. What day is it today? 3/10/25. I like to label. I like to date my stuff so I know what we did and when we did it, and then I can go back and make it better. Yeah, but I like the fraction one. That was a good one. Okay. If there's no other questions, I will sign off. Thank you again. Thank you everybody for joining me, and I will see you in my next live. I'll see you in my next live. Thank you so much, everybody. Have a good night.